I'm sharing my screen. So let me share screen.
Is it just mute? Okay, never mind.
So can you all see the screen?
Yeah.
Yeah, we can.
So everybody go to the link and enter the code.
Hey everyone, in the announcements you can see the link. So all you have to do is go to the link. Sagar, can you just read out the code once?
Yeah. So the code is 280728. Already 4 people have joined, so it's working. So the code is 280728.
Yeah.
And
So, huh.
and Hardik and Sitara, can you share the quizzes link and the code to WhatsApp group and even the Telegram groups?
Yeah, I've
Yeah,
done
I'll
that.
do that. Yeah. Yeah. So here, whoever is here, you can go to the announcements channel and just log in over there.
So if anyone have any doubts or any questions during the quiz, you can post it in the astrophysics channel. Under STEM classrooms, we have this channel called as astrophysics, second channel. So there you can post your doubts or questions. We have about 30 people joined right now. So can we start?
So can you hear my voice? Is it okay, guys? Can I get some responses?
Yes, yeah, it's okay now.
Okay. So I'm starting the quiz. We have 41 people right now. So even if I start, even then new people can join. They have to just enter the code. Okay. So I'll be starting. So are you all ready? Oh, just now someone joined. So are you all ready, guys? Audience, participants, guys. You can respond. Okay. So the first question. Which of these is not a messenger for astronomy? Electromagnetic waves, cosmic rays, neutrons, gravitational waves. So what is the answer? So the answer is neutrons. Now why neutrons? Because neutrons are not actually messengers, as free neutrons decay to proton and electron. Rather, neutrino is the left out messenger here. And one instruction is all have to answer within the time limit, because if the time limit is crossed, then you can't answer. So please try to answer within time limit and don't try to Google, because Googling takes time. So in the next question. So the second question is, identify the telescope which is about to launch in the near future. So which is the telescope which is about to launch? So you have 4 images. Choose the correct one. So 39 people have answered, and the correct answer is the James Webb Telescope, which is the 4th option. So it is about to be launched on 31st October 2021, and 3 other telescopes have already been launched. So the next question. So supernova is known to emit what of the following? More than one option is correct. So is it cosmic rays, neutrino, electromagnetic waves, and gravitational waves? Which are the correct options? Fast, the timer is gone. Many have been not able to answer. Yeah. So fast. So I'll go to next question. Now, before you go to next question, supernova are very huge cataclysmic events that can produce all the types of messengers. So they are cosmic rays, EM waves, neutrinos, even gravitational waves. So they can produce all the types of messengers. So many are not able to answer, but I'm telling again and again, please answer before the timer goes. You can see the timer in your device. So the next question. So DUNE is an experiment to detect which of the following messenger? First, 6 seconds remaining. Yeah, 42 have answered. So the correct answer is none of the above, because DUNE is Deep Underground Neutrino Experiment, which is an under construction experiment at Fermilab in US. So DUNE detects neutrino, and it is not any of the particles which are mentioned here. So the next question. Which messenger of astronomy played an important role in getting this image? So here we have an image, and which messenger played an important role? Is it gravitational waves, neutrino, electromagnetic waves, or cosmic rays? So the correct answer is electromagnetic waves. Now it was specifically radio frequencies which they used to get this image of black hole, which is at the center of M87 galaxy. The magnetic field lines which you see here is because of the polarization states of that radio frequency. So the next question. So the question is, identify this. What is that which is shown in this image? So is it microwave telescope or UV telescope or IR or radio? Which telescope is that? So the answer is, it is radio telescope. Now this radio telescope is actually at Parkes Observatory, which was used mainly to get live televised video. And moreover, the antenna what you see here is because it's an exclusive feature of radio telescopes, because the antenna width, the antenna mesh size matches with their frequency. Okay, so we go to the next question. Which could be the hottest star among the following? So is it bluish white star or red star or yellow or indigo colored star or orange star? So which is that star? Okay. So the answer is blue color. That is the fourth option. Because we know that higher the frequency or lower the wavelength, then the hotter the body is. And moreover, by Planck's distribution law and Wien's displacement law, the frequency and temperature are linearly related. That is, as the frequency increases, the temperature also increases. So it is this fourth option. Now we go to the next question. So what does this image depict? Is it absorption spectral lines, emission spectral lines, continuous spectral lines, or none of the above? Fast. So which could be the answer? So the answer is emission spectral lines. Now why emission? Because we can see the particular frequency light and which are being emitted by the elements which are sodium, hydrogen, calcium and mercury. So they are the spectral lines of these elements. And moreover, you can see in the black background, there are particular wavelengths mentioned. So they are emission spectral lines. So now if you go to the leaderboard, actually leaderboard I'm not getting. Let us see. Now next question. So which messenger of astronomy is not a fundamental particle? Neutrino, electromagnetic waves, cosmic rays, gravitational waves. Fast. The timer is about to end. So I'll end the question. So the answer is So we can see the leaderboard here. First is Bharat and then Anunay, and we go. And the answer is actually cosmic rays, because we know that neutrino belongs to the fundamental particles. They can't be divided. Electromagnetic waves are photons actually, and they also can't be divided. They are fundamental. And gravitational waves, which are theorized to be gravitons, they are also fundamental particles. But cosmic rays are made of nuclei of atoms which contain proton and neutron. So they are not fundamental. So cosmic rays is the correct answer. Many have said gravitational waves, but gravitational wave, why it is not a correct answer? Because we have a theory which is not experimentally detected but theoretically sound. That is, gravitational waves have this quantized material called as gravitons. But cosmic rays, clearly it is having a nuclei of heavier atoms. So those nuclei have neutron and proton. So they are the correct answer, because neutron and proton are not fundamental particles. So next question. So what types of waves are gravitational waves? So here you can see the GF image. This is transverse dipolar, longitudinal dipolar, or transverse quadrupolar, or longitudinal quadrupolar. Fast. Many have not answered. Try answering a bit fast. So actually gravitational waves are transverse waves and quadrupolar in nature. And why transverse? Because the space-time oscillates perpendicularly to the direction of propagation. So now we know that space-time is the medium for gravitational wave, and that space-time oscillates perpendicularly to the direction of propagation of the wave. So this is transverse nature. And why quadrupolar? Because they arise due to the change in the quadrupole moment of the sources. So the change in quadrupole moment generates this gravitational waves. So they are quadrupolar in nature. So next question. So what is the principle behind this detector? You can see the detector is actually very small, but one thing you can note down the shape of the detector. So what is the detector? And what is the principle behind the detector? Is it superposition, interference, diffraction, refraction? And note, it is multiple choice question and more than one option is correct. So we have 5 seconds remaining. Fast. I'm ending it. So the answer is superposition as well as interference, because we know that the LIGO detector uses the principle of both superposition of light. That is, when two lights interfere, that is superposition, and the pattern what they produce in the photo detector, that is interference. So both the principle are used here. So next question. So arrange the phases of gravitational wave production to in spiral mechanism. Spiraling, merger, ring down, or merger, spiraling, ring down, spiraling, merger, or spiraling, ring down, merger. So which is the correct option? We have 5 seconds remaining. Fast. Okay. So the correct answer is spiraling phase, then merger, and then ring down. So first what happens is two bodies revolve each other while emitting gravitational waves, that is spiraling phase. Then they merge together where the amplitude of the wave reaches a peak, and then suddenly when the bodies become stable, the gravitational wave stops. So that is ring down phase. So spiraling phase, merger phase, and then ring down phase. So the next question. Which type of gravitational wave is hard to detect? More than one option is correct. So which are those gravitational waves which are very hard to detect? Only 5 seconds remaining. Fast. Still half of them have to answer. Fast, guys. So which gravitational waves are hard to detect? So I stopped the question. This is response. So the answer is actually compact binary and continuous gravitational waves can be detected easily because they are having a longer duration of gravitational waves and the lifetime of gravitational wave is longer. But for stochastic and burst gravitational waves, their lifetime is very, very small, and stochastic, it is very, very random, so we can't easily probe the detector in stochastic wave. And burst gravitational waves are very, very short lived, so stochastic and burst gravitational wave is the answer. The next question. Core collapse supernova emits this messenger abundantly. So which messenger is emitted abundantly from core collapse supernova? So only 5 seconds remaining. Fast. I'm stopping the responses. Yeah, done. So the answer is neutrinos, because 90% of the particles which are emitted by neutrino, that is 90% by number, will be neutrinos, because neutrinos are emitted abundantly. So the answer is neutrino. So now we go to the next question. Which of the following has its charge and its antiparticles charge both to be equal to 0? And more than one option is correct. So which particle and its antiparticle, both charges is 0? Is it muon, electron, tau neutrinos, or cosmic ray particles? Fast, the timer is going. So I'm stopping the responses. 3, 2, 1. So the leaderboard we have Bharat leading, and then Aditya Srivatsa, and then Aruna. So the answer is all neutrinos, that is muon neutrino, electron neutrino, and tau neutrino. So all these neutrinos are chargeless, and even their antiparticles charge is 0. Then how do they differ is based on the chirality and lepton numbers, the antiparticles and the normal particles of neutrinos will differ based on chirality and lepton number. The answer is all these neutrinos. So now next question. Which is the main nuclear reaction that occurs in a core collapse supernova? So which is the main nuclear reaction, occurring in a core collapse supernova? So we have 25 seconds remaining. Fast, try to answer.
I think we can give them maybe 6 seconds, a little bit extra for this question.
Okay. So I'm giving 10 seconds extra. Please try to answer. Now, you no need to be a particle physics researcher to know the answer. Basic ideas are enough to guess the correct answer. Okay, I'll end the responses in 5, 4, 3, 2, and 1. Yeah. So if we see the leaderboard, we have first Bharat, and then Aruna, Aditya, Anunay, and the name, right? So now if we try to guess, if you know actually particle physics, then you can guess what is the correct answer. Now we know that in supernova, the core is gravitationally collapsed so much that all the atoms will come very very close to each other, and when they are compressed a lot, the proton and electron will combine to form neutron and electron neutrino. So that reaction happens, and thus all the atoms on the atoms will become neutrons, and thus it turn out to be a neutron star. Now the further reactions are complex. Now if you know basic ideas like conservation of charge and mass, you can guess the correct answer. Here you can see in the first option, electron anti-neutrino is emitted. So that is not abundant in supernova, so the first option has gone. If you see third option, proton is giving neutron, electron, and electron neutrino. Now there, the conservation of mass and charge both are violated. How can plus charge become minus charge in a system? And moreover, proton is lower in mass. It can't give rise to neutron, which is higher in mass, and moreover, an electron. So that option is also gone. If you see fourth option, antiproton and positron are giving neutron and electron neutrino. Now, antimatter abundance is very very small as far as I know. So even that can't be correct answer. So the only option remaining is second option, where proton and electron will give neutron and electron neutrino. The second option is correct. If you see, many of them, 31 people have given correct answer. So nice. So next question. And the question is, which detector, the detector of ice cube neutrino observatory is most sensitive to the following? So which neutrino is easily detected, or ice cube neutrino detects this neutrino easily, or it is sensitive? So which is that? We have about half of the people remaining. Try to answer fast. So I'm ending the responses in 5, 4, 3, 2, 1. If we see leaderboard, Bharat is leading, and then Aruna, Aditya, Anhad, and Sanat Kumar. The correct answer is muon neutrino. Now, why muon neutrino? Because muon neutrino has this property of leaving the longest trails or tracks which they produce, and moreover, it is most penetrating. So that is why muon neutrino is easily detected, and ice cube neutrino observatory is sensitive to muon neutrino. So I'm going to, and moreover, we finished 17 questions and 13 more questions remaining. So the main reason why neutrinos are least interactive, what are the main reason neutrinos are least interactive? More than one question, more than one option is correct. So 20 seconds remaining, and more than one option is correct. Fast. We have 45 people remaining. I'm stopping the responses in.
Yeah, give them a
5,
couple of
4.
more seconds. Give them
Okay, I'll
5
give
more
10
seconds.
seconds.
Yeah.
Okay.
Out of 75, I think usually only 50 people are able to answer. So guys, if you're here, please try to the rest of you also please attempt it. Okay, you can end in 5
Stopping
seconds.
the response in 5, 4, 3, 2, 1. So we'll see the leaderboard. So we have Bharat, Aruna, Aditya, Anhad, and Sanat Kumar. So others, give correct answers fast. So now, if you want to analyze this question, now first we need to know what is the basic property. Like now neutrinos don't have charge, so that makes them very tough to detect by electric or magnetic fields. So that could be an option. So that is the correct answer. And neutrinos participate only through weak interaction, and that is actually a very advantageous, but rather it is also very tough for us to detect neutrinos because of the very same reason, because they participate only through weak interactions. Moreover, they are very rare and short range. And why the first option, that is rest mass of neutrino is much smaller than other known particles? That is not the correct option, because we know these photons, which are the force carrier of electromagnetic waves. They don't have mass at all, but it is still easy to detect them. So that is not the correct option. And moreover, neutrino oscillations, that is not necessary, because that means just the neutrinos are changing their form to other neutrinos. That is, the flavor is changing, and that doesn't add any disadvantage. But the main reason is the second and fourth option. So next question. So what does this Feynman diagram represent? More than one option is correct. So what does this Feynman diagram represent? Now you no need to be a particle physics researcher again to answer this. Just you need to follow the direction of time, and then you'll find out the answer. So the correct answer is, we have leaderboard. You can see. Now many people have answered fourth option and third option and first option. Yeah, it's okay. But the correct answer is first option, second option, and third option. The reason is, in this Feynman diagram, we can see a neutron, according to the direction of time, it is becoming a proton, and with the interaction of W minus, it is becoming electron antineutrino and an electron. So that is nothing but the fourth option. Okay. Now it is also neutron decay, because neutron is becoming or changing into these particles. It is neutron decay. Okay. And it is also beta minus decay, because electron minus is being ejected. Now if you see any beta minus decay, the main reaction is the same reaction which is happening. The neutron of that nuclei becomes a proton, and it emits an electron. So that is beta minus decay, and that is nothing but neutron decay and this fourth option as well. So first option, third option, and fourth option, all three are correct. So we are going to 20th question. So identify this detector. It is pretty easy, but you should know the basics. So is it Super Kamiokande? Is it Ice Cube? Is it Albos? Or is it Tracer? Which detector it is? So we have leaderboard. Aditya came to the second place and Loki is in fifth place. These are the new additions. So if we see this is nothing but Super Kamiokande detector in Japan. This is a very good neutrino detector, which Japan scientists are building now. So it is present in Japan and it is Super Kamiokande detector. So next question. So what is the phenomenon observed when a particle is moving in a medium that is more than the speed of light? The speed of particle in medium is more than the speed of light in that particular medium. It is a bit tricky question. I'll give some extra time to answer. So what is that phenomenon observed when speed of particle in a medium is more than the speed of light in that medium? Photonic boom, sonic boom, Cherenkov effect, or anomalous dispersion? So I'm ending the responses here. So the correct answer is Cherenkov effect. And if we see how many people have answered correctly, 23 people have answered correctly, not bad. So now, what is the main reason is, in a medium, we know that the speed of light reduces because that is what happens in a medium. That is, when refraction and all, we know that the speed of light decreases in a medium. So, if speed of light decreases to a large extent, then we can create some particles to go speeder. That is, the speed of the particles to be more than speed of light in that medium. Then that produces a radiation, that is a blue color radiation called as Cherenkov radiation. That is called as Cherenkov effect. So next question. Cosmic ray particles are primarily or mostly made of what? Positrons and electrons, helium nuclei, protium nuclei, or neutrinos? So cosmic rays. Yeah, 43 people have answered.
Oh, we should have given a little
correct-
bit more time for this, I think. Anyway, yeah.
So the
Yeah.
correct answer is protium nuclei. Why? Because 90% of cosmic rays are nothing but protons, but protons are nothing but the nuclei of hydrogen. The nuclei of hydrogen with only one proton is called as protium, or the atom is protium, and protium nuclei is nothing but protons. So that is why protium nuclei is the correct answer. And 9% of the cosmic rays are helium nuclei, but they are not abundant. And less than 1% will be positrons and electrons. The correct answer is protium nuclei.
Yeah, before you go to the next question, let's take a 30-second break so that all of you are, just to make sure all of you are on the same page. We see that about 20 to 25 people are not answering the questions. So you can unmute now if there is anything, if you want us to give you a little bit more time, or if you have any questions so far.
Ma'am,
Yeah, hi.
what if we missed out few questions? Can we do them again?
No, if you miss out questions, it won't be counted as part of the points. So
Yeah,
on the
that's okay.
leaderboard, yeah, but later you can, I think, reattempt the quiz.
Fine, that's okay.
Yeah, okay.
Ma'am,
Yeah, tell me.
Like while you're giving a question and then you're like stopping the time, like just give a thing like you're stopping it before 5 seconds or something.
Yeah, okay. Yeah, Sagar will do a 5, 2, 1 countdown.
Yeah,
So and
because
then
like when
we'll
you do it
end.
all sudden, no, don't get to know.
Correct. Yeah. So he'll do a 5 to 1 countdown then. Okay.
Yeah, yeah. Thank
All
you.
right. Yeah, one more thing. So, all of you here, please don't leave this Discord call before the entire quiz ends. We are planning to give a participation certificate, but especially to the top 10 people on the quiz, we have something special. So, please don't leave this Discord call before the quiz ends. So, there'll be a small Google form that you have to fill if you have attempted the quiz. So yeah, just make sure you do that. Okay, I think we can continue. If anybody else has anything to say. Uh, okay, all cool. Yeah, Sagar, continue. And make sure you
So we
just
have
give them a
completed.
5 to 1 countdown
Yeah.
before you end. Yeah.
Okay. So we have completed 22 questions and 8 questions are remaining. Okay. So the next question. So which of the following protect us from cosmic rays? More than one option is correct. So we have 20 seconds remaining. The answer: Earth's magnetic field or atmosphere, ozone layer, all of the above. So which is the correct answer? So 5, 4, 3, 2, and I'm ending the responses in 1 second. Yeah. So the correct answer is Earth's magnetic field and atmosphere. Why? Because we know cosmic ray particles are charged particles, as we saw in the previous question. So Earth's magnetic field can easily deflect these charged particles. That is one of the most useful properties of Earth's magnetic field is this. They protect us from cosmic rays, and even atmosphere protects us because if some cosmic ray particles enter atmosphere somehow, the ionosphere layer of our atmosphere, it is consisting of charged particles, so they attract and they don't allow further penetration of cosmic ray particles. And why it is not ozone layer? Because ozone layer mainly protects us from UV rays. So the UV rays are not cosmic rays, rather they're electromagnetic waves. The correct answer is Earth's magnetic field and atmosphere. So next question. What was the method used to find the void in Great Pyramids of Giza, Egypt? Is it electron tomography, muon tomography, or tau tomography? None of the above. I disabled the timer because we need to know the question. So I'm ending the responses in 5, 4, 3, 2, and 1. So the correct answer is, it is muon tomography. Now why muon tomography? Because has a property of more penetration property, that is, than compared to electron and tau, muon has more penetration property and forms trails. So they easily create tomographic image, that is the 3D tomographic images, and that is how the scientists used to find the void in the Great Pyramid. So when they streamed muons into the pyramids, they found out, the tomographic image found out that there is void in the Great Pyramids of Giza. So that property of muon is used here. The answer is muon tomography. So next question. What is the highest possible total collision energy of LHC? Is it 14 TeV, 10 TeV, 8 TeV, or 13 TeV? TeV means tera electron volts. I'm stopping the responses in 5, 4, 3.
No, give them a
2.
couple of more seconds, no?
Okay.
Yeah, let's give them 5 more seconds. It's okay.
We have 44 responses, 24 remaining, 34 remaining.
Okay, yeah, you can count down from 5.
5, 4, 3, 2, and 1. So the correct answer is 13 TeV. Now, why 13 TeV? Because okay, we have leaderboard. We have Bharat, Aditya, Loki, Kishle leading. So now why 13 tera electron volts? Because now Large Hadron Collider tries to mimic the Big Bang, isn't it? By creating more energy and temperature. The main function of Large Hadron Collider is to create the condition of Big Bang such that the particles which were present in that era of Big Bang, they are produced. Now 13 TeV corresponds to the quark epoch, that is the region, that is the time where quarks and gluons were dominating the universe. So in that epoch, the temperature or the energy was 13 TeV. So that energy is being created by LHC till date, but they can't increase it because of the safety concerns. If they go for higher tera electron volts, then they might reach some catastrophic problems might occur. So that is one reason. And moreover, if they are upgrading also, they are not able to achieve the higher energy. So 13 tera electron volt was achieved in 2015, and till now the 13 electron volt, tera electron volt itself is the highest energy of LHC. So we are going to the next question. What is the limit that dictates how far can cosmic rays come from? So what is that limit that tells how far can cosmic rays come from? Is it
Yeah, I will give them
GZK?
2-3 seconds more for this.
Is it GZK limit or Planck limit, vector Hesses limit, or speed limit? So I'm stopping the response in 5, 4, 3, 2, and 1. So the correct answer is Bresson, Zatspin, Kuzmin limit. So that is nothing but GZK limit. That limit is actually derived from the energy and speed calculation of cosmic rays. So now they find out the highest possible speed that a particle or a cosmic ray particle can come from, and that is how they find out the maximum place, that is this distance what they have traveled, and then they find out a limit that is called as GZK limit. That limit actually find out the energy and speed. Using energy and speed, they find out the highest possible distance. Okay, we are going to next question. So what is the occurrence rate of gamma ray burst? About 100 per solar system, proportional to the number of stars in a galaxy, a few per galaxy cluster per year, a few per galaxy per million years. So what is the answer?
Yeah, once again, let's give them 5 to 10 seconds more.
Ma'am, it didn't let me submit.
What is it saying?
Waiting. It shows submitted and waiting for others' answer. I didn't even press it till now.
Oh, it already says. Oh, you must have accidentally clicked on some answer, I think.
Yeah.
Have you already, does it show that you've already selected something?
No, wait, no, it doesn't.
Okay, just try to select and then submit again. We'll count down from 5 starting now. 5,
4,
4,
3, 2.
2, 1.
Yeah, it's done.
Okay.
I stop the responses. So the correct answer is a few per galaxy per million years. Now, now about 100 per solar system cannot be, because in one solar system there is one star. How can there be 100 gamma ray bursts in one solar system? So that is not the correct option. And proportional to the number of stars in a galaxy, even that is not correct, because no more the number of stars, that doesn't mean more gamma ray bursts, because we have to calculate the mass and what is the factor affecting it to become gamma ray bursts, and adding all those factors, that can't be proportional. And a few per galaxy cluster per million year, even that is that is not the correct option, because the correct option is a few per galaxy per million years. That is, they're not too rare, not too frequent. So such a condition, and a few per galaxy cluster per million per year is also a high quantity, because in 1 year there can be so many. That too, when combining all galaxies in 1 year itself, there can be a few. It is very rare actually. So a few per galaxy per million years. So that is the correct option. So we are going to the next question. So what were the Vela satellites originally designed for? The time limit is very small. We have 9 seconds remaining. I'll give like 5 seconds extra.
Yeah, you can just give them some time to read.
So
How
I'm
many
ending the
questions
response
left, Sagar?
we have like 3. No, not
Okay.
even 3. We have 2 questions remaining. I'm ending in 5, 4, 3, 2, and 1. So the correct answer is detection of the covert nuclear weapons test. Now, originally, the government did build the Vela satellites for that reason, to detect the nuclear weapons in space. That was the main reason for Vela satellites. But now they are being used to detect even gamma ray burst. The original design was for detecting nuclear weapons in space. That is the correct answer. The last second question.
Hardik, I think it accidentally detected gamma ray burst, right?
Yes. Vela satellites
Okay.
accidentally.
Okay.
So the distribution of gamma ray burst is prominent near the large Magellanic Cloud, isotropic or uniformly distributed, prominent near Sagittarius A, none of the above. So I'll give like 10 seconds extra. So I'm stopping the responses in 5, 4, 3, 2, and 1. So if we see the leaderboard, we have Bharat, Aditya, Loki, Sai Tej leading.
Yeah, we have we have a really dynamic leaderboard. It's been very interesting how people have been moving up and down. I think there's a tight competition amongst the top 10. So we'll see who make it to top 3 by the end. I think there's only one more question left. Okay.
Yeah. So the correct answer is, it is isotropic or uniformly distributed, because gamma ray burst is having a property that is, in a galaxy it can be the gamma ray burst can happen randomly, and that is uniformly distributed throughout the universe. So there are many factors, including they say the final result to be isotropic. So the last question. So which satellite first detected the X-ray afterglow of a gamma ray burst? Deposac, Coastal Gauss, Vela, or Chandra X-ray? So I gave 10 seconds extra for this question. So the responses, and in 1 second. The time's up. So we have leaderboard. Bharat, Aditya, Saitej, Loki, and Kishle.
Are all the questions over?
So, yeah, all questions are over, and let me explain this last question. So Beposac is the correct answer because that detected the X-ray afterglow of gamma ray burst in 1997 itself.
Sagar, it's just
So
still waiting for people to answer.
no,
Okay, then never mind.
so the correct answer is Beposac.
It doesn't show green for Vaposax. I think something's up. I don't know. But
There is a bug. And moreover, I
maybe-
can't access the leaderboard between the questions.
yeah,
There should be
we'll
a
have to end the
leaderboard.
question. No, you have to end the quiz to answer to access the leaderboard, I think. But yeah, I think you were just explaining the last question. Go ahead.
Yeah. So Beposax was detected the gamma ray burst in 1997 itself, and X-ray afterglow, because we know gamma ray will be redshifted to X-rays, so that afterglow of gamma ray burst was detected by Beposax. So we have leaderboard here.
Let's go through this properly. Can you scroll up once?
Yeah, the first is Bharat.
Okay, so congratulations, Bharat, for winning the quiz and being the topper, I guess. And then there is Aditya, Saitej, Loki, Kishle, Sanat Kumar, Amal J, Aruna, Akash, and Anhad, who are in the top 10 performers of the quiz. But congratulations to everyone, guys. I think it was fun. A lot of you may or may not have had a background in the topics that we studied, so it's nice that all of you participated. I think it would be interesting to have a slightly longer conversation about the topics that we saw today. But before that, would somebody in the top 3, 4, or top 10, would anyone like to unmute and talk about which question did you find hard? Was there any comments about the quiz? Bharat, anybody else from the top 10?
So
Okay,
you can
hello.
see many people
I'm
joined
Aditya.
late, and
Yeah, hi Aditya.
Okay, yeah. So one of the main problem was like the lack of time. Like I know you told you're gonna extend the time, but you told that after I already submitted my answer. So for a lot of the questions, like for example, the what happens, the nuclear reaction when the core collapse, right? Like I knew proton converts into a neutron. Like I knew it was like an electron taking it, but the time was running out, so I answered the second option. Like I didn't even bother to look at the charge because there's no time. And then
Oh,
you
so
said
you
time
saw the
extension, and then I
timer.
saw the options, and I'm like, oh wait, it's pretty obvious.
Okay. Yeah, I think it should be maybe about 40 seconds of per
Yeah, like
question.
if we'd known from the
yeah.
start, I could have at least like read the question.
Right, okay. That's a good feedback.
But
But
yeah,
I think the timer was
that's the only thing about it. Rest all is pretty cool. Thank you.
okay, cool. Thank you. Yeah, I think the timer was on, but we were disabling it to extend it, so it might have been a bit confusing. But okay, anybody else from the top 10?
Hi, Aruna.
Oh, hi, Arna.
Hi.
Congrats.
So I found it, I didn't know a lot of, especially the sat.
Your voice is kind of breaking. Can you repeat that, Aruna?
Okay, so I found the fact question a bit harder. I didn't
Okay.
know a lot,
Right.
so
Yeah.
that was a bit hard. And even the picture-based question.
Okay. Okay. Yeah, I saw that a lot of people were first sometimes in the third place and then they went down to sixth place. So yeah, pretty dynamic leaderboard. So on the, I think highlights, it says that the toughest question was, can you click on that toughest question? Sagar, question 18, no? The main reasons why neutrinos are least interactive. Wow. Only 12, okay, 39 players got it right, I think.
Now, what
But
is the main? What is the tough thing is choosing multiple answers. That is, they
yeah,
might choose only
correct.
one correct answer.
Correct.
That's
Yeah.
what.
Okay.
I'm Lohit and I have the name Loki over here. So I felt the specified questions like naming the satellites and stuff that was a little hard for me. So I thought like it was not that very generalized. Like people have generalized knowledge. I mean, varied knowledge over here. So these questions, I felt that it was a very specified kind of thing. I mean, it was hard for
Yeah,
me.
they're specific. They're specific to multi-messenger astronomy. So you can continue.
Correct. Yeah, yeah, that makes sense. So yeah, a lot of it was specific to multi-messenger astronomy. But I think yeah, I think about 5 to 6 questions were factual, and then some of them were more generic or analytical. So okay, is anyone else comments?
Hello.
Yeah, hi.
Hi. I mean, I agree with what everyone else said. I mean, it is good to enjoy the general type questions, but at the same time, some of them are really specific and hard to understand unless we take up a higher course or anything of that sort, or we have any specific interests. But
Yeah.
even in
Yeah.
that case, it is really fun to learn something new. So that's a thought.
Okay, cool. Thank you. How many of them got the cameo Kande right? I don't know. Can you see like the percentage of? Oh yeah, you can see it.
Yeah, Kamya Konde was.
Okay. Anyway, yeah,
So if we
I'm at
go
least.
by,
Uh-huh.
Kamya Konde was a bit later.
Correct. Yeah, yeah. So anyway, so we hope you learned a couple of things or two. But this was really just an a way for us to kind of summarize or rather give you guys a glimpse of what this field contains, right? So the reason we were trying to be a bit more specific, firstly, is because our theme is multi-messenger astronomy and astrophysics, but also the upcoming projects. We wanted to know if there are students amongst you who are a little bit more well informed about this specifically. So, multi-messenger, while it is pretty broad and multidisciplinary, it deals a lot with astroparticle physics, gravitational waves, neutrinos, and as you know, cosmic rays. So, these are the four messengers, right? So, there's a lot of astroparticle physics involved. And yeah, so that's a little bit niche. So, the summer research projects that we are going to be doing are going to be directed towards these topics. So, except for the one which is electromagnetic waves, which are usually a bit, everyone knows about them, and it's something that all of us study generally about electromagnetic waves. But we will be focusing on gamma rays and gamma ray bursts and how they are related to supernova. So the two groups, the first one is neutrino group and the second one is going to be the gamma ray group. They are both going to study the messengers in the context of supernova explosions. So what kind of for example, neutrinos, what are the sources of these neutrinos in the context of supernova explosions? Why do they produce neutrinos, and what can we learn from them, and how do we detect them? So that is the topic of the first one. And secondly, what are gamma ray bursts? Why are they the most energetic, phenomena producing the most amount of gamma ray flux that we know of in the universe? So the processes that underlie these phenomena is what we are interested in. which is why you might have found some of the questions really specific. We wanted to know if there are a few students who are probably worked on it or are more inclined towards the specific field. But yeah, it was really just a means of, for learning. All of us who set the questions also learned a lot. So coming to the end of the program, I think it took us about 45 minutes to finish the quiz. So once again, congrats. So I'll be sharing a form on the announcements channel, and if all of you are interested enough, we can do a second quiz next weekend because the summer projects start on 28th. So it'll be great to start the projects off with another quiz, and we'll take all your feedback and try to make it a little bit more I guess conducive. So I'll be putting a link on the announcements channel. The first link is a Google form, which if you're in the top 10, you should mandatorily fill, or if you're interested in just getting a participation certificate, you can go ahead and put that here. You can fill the form. Just a minute. Yeah, and the second link I'm going to leave is for learn.nakshatra, which is our website where you can go ahead and enroll for these summer research projects. Just to give you a glimpse of what the summer research projects are, I'll just talk about that in one sec. So this is so please check your announcement. That's the feedback form.
So I want to add something now. Why the time limit was very small or very short? Because, and one thing is, many people will try to Google, and I've seen that. So to prevent that, I kept the time limit small, and I think it became really too small. But and one thing we have to learn is in very small time how we will try to analyze things quickly. That is one
I
of the
think
important
someone
skills.
wanted to say something. Yeah, go ahead.
Who is that?
Yes, sir. One.
I think it was Steve.
Yeah, like yeah. So if we even like if you can increase the time, because if like in quizzes I've seen it, if you even go change your tab, it will auto submit the answer. So like that wouldn't be an issue, because when my answer was auto submitted, I got a notification on somewhere else. I shifted the tab and the answer was auto submitted. So that is not the problem.
Oh, did you
Just tell
observe that today on quizzes?
right now. Yeah, right now, because I got a notification and then I went there and I came back, then our answers auto submitted. When I told you that my answers auto submitted, I just realized that happened.
Oh, okay. We did not know that. That is great. Okay. That
Yeah,
solves the
so
problem. We were basically concerned that people will start Googling it, but
yeah.
yeah, I mean, that's
And the
great.
questions are so specific, you can't even Google them out. I mean, and like within 15 to 20 seconds, the answers cannot be Googled so easily.
Exactly. Yeah. Some of
Yeah.
them is more like you have to think,
Yeah.
so you can't exactly
Think.
Google. So, all right. So next quiz, we'll keep it a minute long per question, and we'll give you guys enough time. So yeah, definitely watch out for the next one. I think it'll be fun to start the projects as well. Yeah.
You can
Anybody else?
you can keep the time limit as 40 to 30 seconds, because like 1 minute, people will find out ways.
Okay.
Yeah,
40
so
seconds then. Okay.
yeah, like suggestion, it's up to you.
Yeah, sure. Okay. 40 seconds seems like the
Excuse
sweet
me.
spot.
Yeah.
Yeah.
Although I was not in the top 10, but I would like to give a suggestion for the next quiz. I
Sure.
mean, for
Yeah.
all the quizzes conducted further with Nakshatra and Group. So that I think that you should keep some 10 to 15 questions more, I think. So that will make it the quiz more enjoyable, I guess.
Oh, we were thinking of a longer quiz, but we didn't want to bore you guys out, so we just stuck
It
to
is
30
actually not
questions.
boring. I mean, it is not possible for everyone to win, but at least it gives you a better insight over the entire topic, maybe.
Okay. Yeah, we would love to have had a longer quiz. So initially it was just 25 and we made it 30 questions. So we would love to come up with more
Can go a
topics.
bit 30 seconds,
Yeah.
30 questions. I think.
Okay.
And
Mhm.
ma'am, any possibility of like anything you can do is like for retaking the questions, like some are missed, like anything is possible like that? If some question is missed, we can go back and take it.
So this is a live quiz. So during the live quiz, I'm not sure if you can go back. You can't actually, because the person hosting the quiz controls, what everyone sees. But we can, I think, keep the link open. I think there's a possibility for that where you can take it in your pace. I think there is a student paced option. So
It doesn't. I tried now, so I wasn't able to read this.
yeah, you can't do it with the same link. I think he has to generate something called a student paced link or something, which you will be able to take without the timer, right? So maybe we can do that. That won't be a live quiz. So for those of you who want to reattempt it, that's a good option.
Okay.
Okay. Thank you so much for the feedback. We really would have loved to have a longer quiz. We had a lot of different topics to address. So maybe next Sunday, all of you can join in again, and we'll have about maybe 45 questions. That might take longer, but it'll be fun, I think. And we'll keep the duration longer as well. Also, I thought it would be really fun to have a discussion, a small discussion after each question. Today, there was not much time, so only Sagar had time to comment on what the answer was. But next time, we will have 2 minutes perhaps where anyone can unmute, and anyone who got the answer right can maybe unmute and talk about why they picked that answer. So that will be very interesting. So we'll do that next time. And if you guess the answer, we'll know. But those of you who have good explanations, it'll be nice to learn from you. So that is also something we'll do.
Hello.
Yeah, hi.
Yeah, so I had one more suggestion.
Sure.
Is there can you disable the points which are given if you answer the earlier than others? Because that was a bit what to say. I was choosing answers very quickly without even reading properly, thinking that I will get more points if I answer faster than others. So that was little bit putting me off.
First of all, we used an entirely different platform called Quizzes. So I think they have designed the leaderboard, they have a bunch of parameters. I think one is perhaps speed. I don't know if we can disable it, but we'll surely look in. Also, there is a possibility we might host the quiz on a different platform this time. And I think that will make it easier for everyone here. So don't worry about that. We can also make it such that there is a timer, and it will be on a platform which is created by Nakshatra. So if that is possible, we'll be able to customize it. Okay, I'll give you guys 30 more seconds. Anything else?
I generated the permanent link, so I posted in Astrophysics channel. So if you go to the link, you can answer the quizzes how many times you want.
Okay, thank you, Sagar. Yeah, I think that should work. You should be able to attempt the quiz now, those of you who want to just reattempt it again. And Jeevan, if you're here, can you post the YouTube link on announcements as well? So this session is getting live streamed, so I guess later you can go check that as well in case you want to. All right, so coming to the topic of the projects, I guess. So how many of you, okay, I can't take a vote, but I think quite a few of you might have been part of some of our previous programs where we've had a project as part of the course, but this time it's purely the project itself that we are focused on. And this is, I would like to say, 65 to 70% a study project and 35% an implementation project. And the reason for this is 5 weeks is enough time for you to master the fundamentals of a topic, right? And then you have that short window of 2 weeks for you to solve some really interesting problems. So we have tried blending these two things together to make it conducive for everyone. Okay. And one more thing is it is not limited. A lot of students in Nakshatra who've come for a 4-week program have stayed back and written a really amazing review paper, and they've stayed back for a month or two in the community, finishing off what they started. So it's very much up to you as an individual what you do after the 5 weeks. And there'll be a lot of mentors in the community who will give perhaps mentoring sessions or a guest lecture once in a while. There will be something called a journal club. Those of you who've attended Equinox might know about this. So we'll be teaching you guys how to do literature survey and just basically going through papers in a way, even if you don't understand every element of this paper that you're reading, you can still grasp the main aspects of it. So that is, literature survey. And one last thing I would like to announce is that if you go to learn.nakshatra.com, you see a separate course called LaTeX, right? Research writing with LaTeX. We are making that course completely free for those of you who register for the summer projects. So it's a bonus. It's going to be completely complimentary from our side. And it's just something we want to give as part of the project so that you guys not only learn how to study or whatever, but you also know how to present your work in a professional manner. So we are making that other additional +1 course completely free for anyone who applies for the two of the projects that we've put up. So yeah, that is basically the gist of what you can expect from the project. And the learning outcomes vary depending on which project you pick. One is more oriented towards particle physics, the other one a little bit more on, I guess the high energy astrophysics and electrodynamics side of things. So you can go check out the syllabus on the website, and if you have any questions, you can ask me now. Okay, if there are no immediate questions about the project, I would just like to continue and say that of all the other programs in Nakshatra, we have a coding club of sorts. We do occasional courses for Python programming. I think we have finished about 7 batches for Python programming so far. So if you pick Gamma Ray Summer Project, you have the option of picking a computational group under them so that you can do a little bit of work with data. So that is something you can choose. And I'm just saying this for the people here who already know a bit of programming. But other than that, the Python course is also starting in, I think, 2 or 3 weeks. So that's something else you can look into. There is a free open project happening in Nakshatra right now called Nature of Code Physical Simulations. This is happening every day at 8:30 p.m. on weekdays. So if you're on the server here and you're new, you can just join us every weekday. So Physical Simulations is a project that we've all just, we're very excited about it. We are following a course by Daniel Schiffman, and it's beautiful. We use P5JS or JavaScript to kind of simulate movements in nature. For example, a leaf that is moving in the wind. How do you apply forces on an object? How can you visualize it? So yeah, you can create a lot of cool animations. So that is completely free for anyone to join. And it is there'll be a certificate for people who finish all the, I guess 3 to 4 mini projects that are a part of that course. Okay, I will stop my announcements here. I would really hope to see some of you in the research project that is starting on the 29th. So it'll be great to see some of you there in the 2 different cohorts. If there are any other questions, you can ask. Otherwise, we will announce the next quiz again here, and we will catch you on Sunday.
Hi, ma'am.
Hi.
Ma'am, that you spoke about the summer project. Is it a paid course?
Yeah, the 2 summer projects are a paid course, and the LaTeX they are paid projects, and the LaTeX course comes free with both of them, and you do not have to pay extra for that.
Okay, ma'am. Thank you.
Yeah. You can go to the announcements channel above and just click on learn.nakshatra.com. So yeah, that's where you can apply.
I have a question.
Yeah.
So, how do we apply for the summer projects? I filled up a Google form, but I'm not sure what was the.
Yeah, right now we've made it like a streamlined process where you can go to the LMS. I'm going to quickly share my screen. Those of you who want to do it now can perhaps see it.
Excuse me.
Yeah.
Actually, I have my exams in next month, and so am I able to access this project later on, or able to participate in it?
What you can do is you can enroll now, and you can write as a mail saying you are not able to join this batch. So we'll simply put you in the next batch of the projects. So that is not a problem at all. If you're completely busy and you don't know if you'll be able to